Newton's laws of motion describe the relationship between the motion of an object and the forces acting on it. The first law of motion of Isaac Newton is the law of inertia. This law states that if an object is at rest, it will remain at rest because there's no forces on it. And if an object is in motion, it will tend to keep moving unless it is acted upon by an external force.
Hi, this is the 3 example of law of inertia. Come on, let's go!
The first example is throwing a ball. As you can see, the ball doesn't stop until the dog fetch it and it stopped from moving because of an external force opposed it. The second example is pulling the bill underneath the coin. Due to the coin above, the bill money does not have enough inertia to pull out because of heavy surface on top of it. The third example is removing a paper placed on top of a glass with a coin on top of it. The coin does not have enough inertia to keep the paper from moving, but gravity works on it and the coin falls to the bottom of the cup. Other examples of law of inertia. When you stir coffee and stop, the swirling motion continues due to inertia. And when pedaling a bicycle, if you stop pedaling, then the bike continues going until friction or gravity slows it down. The second law of motion of Isaac Newton is the law of acceleration. This law states that when a constant force acts on a massive body or object, it causes it to accelerate. Or in other words, a force applied to an object at rest causes it to accelerate in the direction of the force. However, if the object is already in motion, the body might appear to speed up, slow down, or change direction depending on the direction of the force of the object and the reference frame are moving relative to each other. This law also says that the greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. In equation form, Newton's second law of motion is the acceleration of a system is directly proportional to and in the same direction as the net external force acting on the system and inversely proportional to its mass. But in more familiar form, when only the magnitude of force and acceleration are considered, this equation is simply the net external force acting on the system is equals to the mass of the object times to its acceleration.
And these are the 3 examples of the second law of motion, the law of acceleration. Come on, let's go!
The first example is kicking a ball. The force was applied on the ball at the same direction, which causes the ball to accelerate. Besides that, the harder the ball is kicked, the stronger the force applied on it, which causes the ball to move away faster. The second example is throwing a ball on its target. The lighter force was applied to the ball to hit the target with a specific distance since the mass of the object is also lighter and small. The third example is opening and closing a door. When closing and opening a door, the acceleration happens due to the force applied on it, which the opposing strength depends on the mass of the door. Other example of law of acceleration is when riding a bicycle, the bicycle acts as a mass and our leg muscle pushing on the pedals of the bicycle is the force. And if you use the same force to push a truck and the car will have more acceleration than the truck because the car has less mass. The third law of motion of Isaac Newton is the law of interaction. This law states that for every action, there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B also exerts an equal and opposite force on object A.
And lastly, these are the 3 examples of law of interaction. Come on, let's go!
The first example is dropping the ball into the floor. When the ball was released and it reaches the floor, it induces downward forces. The ball responds with the same intensity but in the opposite direction through this action. The second example is pressing the balloon inflator. As the balloon inflator was pressed, it released an air which brings an action of giving an opposite same amount of air. The third example is stretching rubber bands. When stretching a rubber band, the size and shape changes, and when the applied force is removed, the rubber band regains its original shape. Other examples of law of interaction. When you jump, your legs apply a force to the ground, and the ground applies an equal and opposite reaction force that propels you into the air. And last, while rowing a boat, when you want to move forward on a boat, you paddle by pushing the water backwards, causing you to move forward.